Hi, I am Dr. Jeffrey Hubona, and welcome to Discover Algorithms for Reward-Based Learning in R by Packt Publishing. Since earning my PhD in Information Systems and Decision Sciences, I have been a university professor teaching undergraduate and graduate information systems and computer science courses for more than 20 years. For the past 7 years, I have been teaching online courses using R software, as well as data analytics and research methods courses, to an international audience. I have many published book chapters, conference papers, and peer-reviewed journal articles. This course provides in-depth instruction about writing so-called model-based and model-free reinforcement learning programs in R. Reinforcement learning is related to machine learning, a branch of artificial intelligence and data analytics. Through the presentation of numerous examples coded using the open source R software version 3.4.0 and the free RStudio desktop version 1.0.143 Integrated Development Environment, or IDE, this course demonstrates many different reinforcement learning algorithms using R-coded examples. The first video provides you with a glimpse of the entire course. Our software is especially well suited to address reinforcement learning problems due to the sophisticated mathematical and statistical capabilities and properties that are inherent in R. Also, R is widely used around the world, and there are many support groups such that an R user can find the answer to just about any R issue by simply Googling that issue online. In the first section, we explain the important distinctions between the model-based and model-free reinforcement learning algorithms or approaches. We look at a race-to-goal problem and demonstrate how to build the reinforcement learning environments, how to find the best policy, and how to validate that policy with several examples coded in R software. We use R examples in every video of this course except for one. It is very useful to understand the algorithms. In the second section, we focus on model-based reinforcement learning algorithms. We examine the state value and state action functions, and then look at our examples demonstrating iterative policy evaluation and improvement, and showing how implementing a discount factor affects policy. The third section focuses on model-free reinforcement learning algorithms, walking through several R examples which implement the Monte Carlo and Q-learning reinforcement learning algorithms. We also discuss the state action reward state action, or so-called SARSA approach. The fourth section expands the coverage of model-free reinforcement learning algorithms, presenting the simulated annealing algorithm as well as a modified Q-learning approach. In the fourth section, we walk through several R examples demonstrating these algorithms. We also present several R examples showing how to visualize the effects of changing Q-learning control parameters on the Q values and on multiple episode rewards. To benefit the most from this practical hands-on material that is presented in this Packt title, it's a good idea for the user to have some basic knowledge of how to use R software and the RStudio IDE. This course uses the open source R software version 3.4.0 and the free RStudio desktop IDE version 1.0.143, which runs on any Mac, Windows, or Linux operating system-based platform. It's also helpful but not necessary to have some prior knowledge of machine learning in general or of reinforcement learning in particular. Upon completing this course, the user will understand the distinction between model-based and model-free approaches to reinforcement learning. They'll know how to use model-based reinforcement learning algorithms by following the examples coded in R. They'll be able to understand and explain model-free Monte Carlo and Q-learning algorithms through the R examples. They will also understand the model-free simulated annealing and our modified Q-learning algorithm through the R examples. Finally, they'll have an appreciation and know how to use the ggplot package, a popular R package, to visualize Q value and reward effects when one varies the level of the control parameters for our modified Q-learning algorithm. Now that we know what lies ahead, let's jump right into the course.